All right, so we're going to move into Unit 4, Section 2, which is going to deal with pH and soil testing. So a little bit of intro. The thing to keep in mind is having healthy soil is equal to a human being being healthy or an animal being healthy. Without the soil being healthy, nothing will grow well. Okay, um, not a lot of productivity is going to happen. So it's important that we are conscious about wherever the area is that we're planting or looking to plant, and we keep it healthy and we replenish what has been taken out, and we don't put too much. All those things. Um, so unfortunately, in certain areas, the health of the soil does not seem to get as much attention as needed. It is a focus that is shifting as we speak. More and more farmers and producers are looking at ways of how we can, not impact the environment as much, and that includes the health of the soil, but also still have high production of crops or other type of products that are being produced. So why do we need soil testing? Well, it's important to know the composition, both or the nutrients and the chemical composition of the soil before you plant anything. Certain plants like slightly acidic soil, certain plants like slightly alkaline soil. Maybe certain plants need more nitrogen or phosphorus than others. So in order to ensure that the base, so to speak, is going to be there for whatever plant you're planting or plan on growing, you need to know what's below the surface. Okay, what's going to be there for the roots to take up? Is there enough organic matter? And we're going to talk about all those things. All right, so some benefits of soil testing. So this encourages plant growth by providing the best fertilizer recommendations. This allows farmers or land managers to produce a plan, uh, to have a script that they're going to go by year to year, and it could change year to year. And that's why it's important to test the soil. But this provides an outlook of what's going to be added, what doesn't need to be added, when it needs to be added, how much needs to be added, in order to ensure that the soil is going to be healthy as possible for the plants to be healthy. All right, so when to take a soil sample? There is a right time and a wrong time to take a soil sample. So it must be taken before planting the new crop, and it has to be taken after you take the previous crop out of the field. It must be taken before the application of organic or chemical fertilizers, and it must be taken 3 months after the last round of fertilizers were added. So places where you do not want to take soil samples from is places or areas where cattle have grazed, under a tree, or anywhere where garbage can be located. The reason you don't want to do it where cattle and garbage is located is because um, compost is going to act as a buffer, a pH buffer, which could give you some false readings and indications on what's actually available in the soil. And under a tree is going to shield that area of gathering or the addition of certain chemicals and nutrients from rainfall, okay, which plays into soil acidity. And also, the tree is going to uptake a lot of nutrients from that area. And so we're actually going to do that takes you're going to test soil, and I'm still working on how that's going to happen virtually. So hang tight and be looking for more messages from me. It doesn't take a lot of soil to do a test, but it does need to be from the samples need to be taken from multiple different areas, and they need to be kind of down in the ground a little bit. Doesn't have to be extremely deep, but you want to get past that grass layer, so to speak, or that initial top layer where the roots are to see what is underneath where the root systems will be, because that is the area that will be taken up by the roots. All right, so plants need 16 essential nutrients for healthy growth. Then you have main nutrients, secondary nutrients, and then nutrients from other sources. So the main nutrients are nitrogen, phosphorus, and potassium. Okay, those are the ones that get a lot of the fame, and those are the ones that a lot of fertilizers are primarily composed of. You can see the secondary nutrients there. They're also important, and you can look through those. I'm not going to read through those. And I also put the atomic symbol on there for those different nutrients, and because that's typically how they're written in manuals. So some nutrients from the air. Of course, you get carbon and hydrogen from the air, and nutrients from the water is oxygen. So apart from the above nutrients, there are some other parameters which also affect plant growth. These parameters are soil pH, soil electrical conductivity, and soil organic carbon. So to judge the health of the soil, these parts should be checked as well. So all of these working together is going to tell us how healthy the soil is. All right, so signs of nutrient deficiency in plants. Okay, it's with the three big ones. Nitrogen. If there's a lack of nitrogen, the leaves are going to become yellow in plants. Phosphorus growth, the plant is going to stop before it reaches that average growth plateau. Potassium, the leaves are going to become reddish, yellow on the edges, while the inner parts of the leaves remain green. And here's the secondary nutrients, some signs there. Again, I'm not going to read through all of these. Feel free to pause this and look at those. These indications will tell us that there's the chemical makeup of the soil is a little off balance. Something's missing, or there's too much of something. There's an issue, and it can start with the chemical and nutrient composition of the soil. Maybe our soil is not as healthy as it needs to be in order to grow these plants. All right, so the pH of the soil, okay, think back to biology or ag bio, or whatever biology class you had. We talked about pH scale, okay, 0 to 14, 7 is the neutral point. The presence or lack thereof of hydrogen ions or OH minus ions is what plays into acidity or basicity of anything, okay? So 1 to 7 is going to be acidic, or 1 to 6 rather is acidic, and above 7 is going to be basic. So pH testing is important because nutrient mobility, which is the transfer of nutrients from soil to plants through roots, it also depends, or this depends on the pH of the soil. So the ideal pH range is going to allow plants to take up nutrients easier. And we can look at this. Okay, you don't have to necessarily put this in your notes. You can find this online. It's a pretty good little chart. You can look and see for most plants which pH range is ideal for the uptake of all of these different nutrients. Okay, so this plays into why it's important for us to know the pH of the soil. All right, so here you can see the soil types based off pH value, okay? And it would go with what you think. Below 4.5 is going to be extremely acidic, and above 9.0 is going to be extremely alkaline, which is basic. You can look at those. You can feel free to write those in your notes, but it just kind of categorizes the pH of the soil. Right, so according to the existing pH of the soil, you're going to use lime powder to increase the pH. So 0.5 to 2.5 tons of lime powder per hectare of farm. So this is if you need to increase the pH. Maybe it's too acidic, okay? Put lime powder down, and this is something that we see done quite often in our area. So let's say you need to reduce the pH. Let's say it's too salty or too basic, or it's too high on the alkaline scale. Um, Leaching can be used. Okay, so we can man-made induce leaching if there are some slopes in the field to push those ions out and down. You could put PVC pipe in there. You could dig trenches. Anything that encourages water to do what it does naturally and kind of speed that up. Also, you can add manure with crops. Okay, again, compost is going to act as a buffer. Right? It's important to remember. For highly alkaline soils, sulfur can be added, and the amount is decided on the basis of the soil type and pH of the soil. And there's different types of sulfur you can add. Here we list gypsum. There's other types. All right, the last slide is organic carbohydrates. I think it's the last slide. Yes, organic carbohydrates. So OC is a measure of organic matter available in the soil. It shouldn't be less than 2%, and it shouldn't be more than 30%. Bacteria grow properly if the OC is in the proper limit. Okay. Now think back again. Here's building off biology. It's important for bacteria to be healthy in the soil because they fix carbon, they fix nitrogen, They fix phosphorus. And remember what carbon and nitrogen fixation is. It's turning inorganic carbon or nitrogen into organic carbon. Okay, so the bacteria play a major role in the growth and development of plants. And so if the soil is not healthy, then bacteria is not going to grow there. And if bacteria is not growing there, then carbon and nitrogen is not getting fixed. If carbon and nitrogen is not getting fixed, then you're not going to have very good plant growth. Okay, so the carbon nitrogen ratio is the ratio between carbon present in the soil and nitrogen present in the soil. You can see there the example. So all living organisms require carbon to produce energy for survival. All right. Be sure you complete the video form with this lecture. If you have questions, let me know. And again, be on the lookout for instructions on how we're going to handle the soil testing lab in a virtual setting. I'm still working on that. I hope to have something ironed out pretty soon. If you need anything, let me know. Thank you.